All right, so I call it Texas popcorn because, you know, you add at the top and then you have the X at the bottom. So it reminds me of Texas, so I know that. So then I do my 10 times 3. What's 10 times 3?
30.
30. I bring my 30 up here. What's 30 plus 5?
35.
So then I bring my popcorn over and it's 35. What's my denominator? 10. So I call it my Texas popcorn. It kind of helps a little bit. If you can't remember, make it mad sometimes. But either way, whichever one, as long as it works for you, you are good. So now, here is the fun part. Like I said, this is no computing. If I see you solving, you're done. You don't compute. Ethan, this one goes for you. You're one of those brain math people that just want to go straight to solving it. All right? You don't solve here. And the reason why, we're going to go over this. We're going to start from the beginning. So Maggie and Braylon, you may start to understand it a little bit better once we get into it. So this is called interpret multiplication as scaling. Or think of it as resizing, okay? Resizing. So here's your standards. Then you're going to be able to explain the size of a product in comparison to the factors. And you'll explain why a product changes when a given number is multiplied by a factor greater than 1 or a factor less than 1, all right? So remember that, greater than 1 or less than 1. So you need to be able to explain why a number by a factor that is less, when you multiply a number by a factor that is less than 1, it gives you a product less than that number. So what that is saying is if I have a number, so my number is going to be 6, and if I multiply 6 by a half, is that a half? Is it greater than, less than, or equal to 1?
More than. It's more
A half.
Greater.
than.
No,
It's
Just one half. Is 1 half greater than 1, less than 1, or equal to 1? It's less than 1. A half is less than 1. So when you multiply these together, you think of multiplication normally as making things bigger, right? However, when you multiply by a fraction, what you do is you're saying that you have 6 1/2. So I have 6 1/2. All right? So therefore, my number is going to be smaller than 6, right? Once you think of it that way. So the rule tells me if I'm comparing this 6 to another 6, all right, the rule tells me if I am multiplying a number by anything that's less than 1, then my product, my answer, is going to be less than that original factor, okay? So if I multiply 6 by a half, it's going to be less than 6. You get that part. So I know just by looking at this, just by looking at it, I can already tell that 6 is going to be greater. And I know that because if I multiply 6 by a half, it's going to be less than 6. I don't have to know how much less it is than 6 because I know 6 is going to be bigger. All right? It's going to be greater than. So that's my first rule. All right? So anytime you multiply an original factor, so this is going to be your original factor, you have that factor and you multiply it by anything less than 1, it gives you a product less than that original factor. What happens, do you think, if you multiply it by a number bigger than 1? So let's say 1 1/2. Is that bigger than 1?
Yes.
1 1/2? Okay. So what do you think is going to be true about this one? Emma?
It's gonna go up 1.
Well, maybe not just 1, it might go up more, but do you think 6 times 1 1/2 is going to be bigger than 6 or less than 6?
Bigger than.
It's going to be greater than 6. So my rule also tells me that if I take a factor and I multiply it by a number greater than 1, then my product or my answer is going to be greater than that original factor, okay? So I can already look at this and I see that this number is bigger than 1 and I'm comparing my 6's. I know this is going to be greater than, okay? My rule also tells me, let's say I have 9 9ths. Greater than, less than, or equal to 1? Equal to 1. What happens if I multiply something by 1?
It stays the same.
It stays the same. So if I'm looking at this, what do you think it's going to be?
Equal to.
equal to, right? So it's going to be equal to. So let's look at that again. So when you multiply a number by a factor that is less than 1, it gives you a product less than that number. All right, so that's our rule. So for example, if you multiply 4 times a third, you get 1 1/3. That's less than 4, right?
Yeah.
So the rule says when you multiply a factor, what's your factor? 4 is your factor, right? Because you multiply factors together and get a what? A product, okay? So when you multiply a factor that is less than 1, all right, is this less than 1 1/3?
Yes.
All right, you get a product less than that number or that original factor, all right? So the product 1 1/3 is less than the original factor 4 because the second factor 1/3 is less than 1. All right, so let's look at some more examples. 6 times or multiplied by 2/3 is that, you already see the answer, but 2/3 greater than, less than, or equal to 1? Less than. So if you multiply by 6, is it going to give you something greater than, less than, or equal to 6? Less than 6. All right, same thing here. All right, Maggie, Braylon, this one's for you guys. My original factor is a half. That is no different. The rule stays the same, whether it's a whole number or a fraction. You're still looking at that original factor, okay? Our second factor is a fourth. Greater than, less than, or equal to 1? Less than 1. So my answer is now going to be less than a half, okay? So it still stays the same, but it's less than a half now. So I know because my second factor was less than 1, my answer is going to be less than a half, okay? And I have some practice problems that should help you guys with this. We're going to do in just a little bit. I just wanted to go over this in case you haven't looked at it. All right, this is the rule. It will always happen when you multiply a number by a fraction less than 1. So anything that you multiply by less than 1, it's always going to be smaller than that original factor. All right? That original factor is the first factor, okay? So then my rule says if you multiply by more than 1, it gives you a product more than the original number. 4 times 5/4. 5/4. Is that bigger than 1, less than 1, equal to 1? Bigger. Always remember, improper fraction and mixed numbers. They're always bigger than 1, right?
Yeah.
So make sure when you're looking at this, you don't get confused and you see just because it's a fraction, you're like, that has to be smaller. Sometimes they're improper fractions. And we know improper fractions are bigger than 1. All right? Now, let's look at some examples of those. So 6 times 8, 6. 8, 6. Is that greater than 1?
Great.
Yes, it's greater. So we know if we multiply 8, 6, and 6 together, it's going to give us a number bigger than 6. It actually gives us 7. So we know it's true. Okay, then let's do a half. All right, here's that fraction again. A half times 6/4. All right, 6/4. Maggie, greater than 1? Yes, it's greater than 1. So we know if we multiply 6/4 and a half together, it's going to give us something bigger than a half, okay? All right, now, it's the same with equals. Equals is always the same, right? So if you know if you have a fraction that's equal to a whole, those are really easy to find. You're pretty good on those. I want to pull up some practice that I have. All right. Multiplication as scaling. So fill in the blanks to complete the sentences. These are our rules, and I really want you guys to nail these down. All right, if you multiply a number by a fraction less than 1, the product will be less than. All right, if you multiply a number by a fraction equal to 1, the product will be equal to that number. What about greater than? It's going to be greater than that number. So do you see how that rule helps you? What I have is people getting confused on the one part. It's just when you're looking at whatever your original factor is, that first one, and what you're multiplying by. Whatever it is that you're multiplying by, that second factor, you want to decide if it's greater than, less than, or equal to 1. And then that's going to tell you if your answer is going to be greater than, less than, or equal to what your original factor was. So let's look at some examples. So I have right here, all right, Aislinn, I have, okay, these are kind of moved around, but we'll look at them anyways. I guess I didn't reset it. All right, 15 times 15 fifteenths. What do you know about that expression?
15 fifteenths is equal to 1, which means it's probably going to be the same as 5, because if you multiply a number by 1, it's going to stay the same.
Awesome. So she knows that 15 fifteenths is a whole, and if you multiply, it is the same as 1, right? If you multiply 15 times 1, you get 15, so we know that expression equals 15. All right, now, give me 1 second, let me do this really quick. I want to, okay, this one's good. All right, so I want you to separate your board into 3. So you have less than, this is an E, equals to, or greater than. And I want you to write the expressions if they're less than 3, greater than 3, or equal to 3. And I want to see what you got. All right, if we're trying to figure out if it's less than 3, equal to 3, or greater than 3, what's our original factor going to be? 3, right? So we know that we need to look at these numbers, the fractions. We're not looking at 3. All right, Emma, can you give me one that's going to go on my less than 3?
The less than 3 would probably be...
You can come up closer if you need to.
Because I can't see.
Yeah, you're fine. Remember, we're looking for something being multiplied by 3 that's less than 1. Less than 1. Anybody want to help her out? Maggie.
3 times 5 eighths.
3 times 5 eighths. So Maggie said 3 times 5 eighths is less than 3. Here's how Maggie knows this. So our rule tells us any number that we multiply by something else, by another number. So these are our factors. Our original factor is right here. All right, so any number that we multiply by our original factor that's less than 1. 5 eighths. Is 5 eighths less than 1, equal to 1, or greater than 1?
It's less.
It's less than, and we know that because it's a fraction, right?
Yes.
And it's not an improper fraction, and it's not a mixed number. It's a fraction because we only have 5 eighths. So we only have part of it, right? So when we multiply those together, we're going to get something less than 3. We don't have to solve for it because our rule tells us that once we multiply by something less than 1, it's going to give us an answer that's less than 3. So we know that it's going to be less than 3. So knowing that, can you find another one that may go with less than 3? We've already done this one.
Another one would be.
So you're probably looking for another one with a fraction.
Another one with
So can you use a mixed number?
No.
No. This is an improper fraction. An improper fraction can also be turned into a mixed number. So can we use that one?
No.
All right. What do you know about 2 halves?
It equals a whole.
It equals a whole, so we're not going to be that one. Whoops. What about this one?
It equals a whole.
Awesome. All right. What
So-
about this one?
That one would. That one's a fraction.
That one's a fraction. Do you think it's going to be less than 3?
Yes.
All right. And you know that. Thank you, Braylon. You know that because it's less than 1. And see, even if it's switched up, we know that we're comparing it to 3, right?
Yes.
So we know to look at the 2 sevenths. So it was 2 sevenths times 3. All right. Kaylin, give me one that's equal to 3.
3 times 9 ninths.
3 times 9 ninths. Is she right?
Yes.
How is she right? 9 ninths is a fraction.
But it equals a whole.
Oh, it's a whole. Exactly. So if I'm multiplying it, even though it's a fraction, it's still a whole. It's 9 ninths. We have all of them.
It makes.
It makes 1. So anytime we multiply something by 1, we get that same number, right? All right, who wants to give me another equal? Maggie.
2 times 3.
2 halves times 3. All right, is she correct?
Yeah.
Yes. All right, Riley, give me one greater than 3.
2 1/3 times 3.
2 1/3 times 3. All right, give me another one, Addison. It's the only one left. 3 times 7 halves. 7 halves is a fraction. What kind of fraction? It's improper. So it's bigger than 1, right? I can turn that into a mixed number if I needed to. But I don't because I know my rule and I know what it says. Alright, so now we're going to do some more comparing. Alright, here's what I like to tell you to do when you're finding these. These are highlighted blue, so it'll make it easier. But go and find what you have in common. What do you have in common between these two? 16, okay? Then, you know you're looking at this fraction. Is 2/3 bigger than 1? So greater than 1, less than 1, or equal to 1?
Less than 1.
Less than 1. So what am I going to put here?
The less than sign.
Less than, right? 2/3 times 16 is less than 16. And I can go through and I can solve these super quick. So Ethan, come and do these two. All right, after Ethan's done, I want Maggie, you're going to come and do these two. All right, then I'm going to have Aislinn, you're going to do these two once Maggie gets done. And then how about I have Jimena, you're going to come and do these two. Okay? Awesome. And then that one. All right, and then those two. Okay, Emma, let's look at this one. Is this correct? It's equals to. 7 times 9/9 is equal to 7.
Yes.
Why is that correct?
Because 9 equals 1.
Exactly. 9/9 equals 1. Riley, 44 times 12/12 is equal to 44. Is that correct? Why?
Because 12 equals to 1 whole.
All right, so you got to get used to explaining these, okay? Because on some of your questions, it's going to ask you to explain how you know this because you're not solving it, right? So you have to explain your thinking. So you could say, I know that 44 multiplied by 12/12 is equal to 44 because when you multiply a number by anything equal to 1, the answer is equal to the original factor, okay? All right, Braylon, 1 1/5 times 2 is greater than 2. Is that right? How do you know?
Because 1 1/5 is smaller than 2.
All right. Greater than 1. We're always comparing it to 1. All right, remember that, 1. Comparing it to 1. But I understand what you're saying because you're saying that when you multiply by this number that's greater than 1 by 2, you're going to get a number greater than 2, right? So I understand that. It does get a little confusing having to compare it to 1 and then know that your product is going to be greater than, less than, or equal to that original factor. But just know that comparing it to that 1 is what helps us know what is going to be true. All right, so I feel like you guys did pretty good on this. I want to look at, let's look at this kind. I have another one that's kind of. All right, so now you're going to order them. You're going to put them in order from least to greatest, okay? Least to greatest. All right, how do we do that? So, we don't solve, all right? We can't solve, that's the thing. We have to look at these. What do all of these have in common, Maggie? What number?
25.
25. I find what I have in common, okay? My rule tells me that if I multiply 25 by a number or a fraction less than 1, it's going to give me a number smaller than 25. 7/18. Less than 1?
Yes.
Yes. I know that this number is going to be smaller than 25. 25 times 7/18. All right? What do I know about 25 times 1 3/4? Is it going to be bigger than 25 or less than 25 or equal to 25?
Larger than 25.
How do I know that?
Because it has a hole in it, which means you will probably be going higher.
Exactly. It has 1 3/4, which is bigger than what? 1. So I know when I multiply by 25, it's going to give me a number bigger than 25. What do I know when I multiply 25 times 4/4?
It's going to be equal to because
It's going to be equal to because of that 4/4. So how do I do this? This is less than 25, equal to 25, greater than 25. I don't have to know what the actual answer is. I don't have to solve it, but I can interpret where it's going to go on this line based on my rules. Okay? Try this one. Good. Good. Awesome. Let's see, it's 12:01. I'm going to keep you guys probably for a few more minutes because I think it'll really help you if you see. I want to do some fraction ones so y'all can see it. I know, but I'm talking like multiplying fractions by fractions, okay? And still being able to interpret it. So, think about, I think you guys will be fine with area tomorrow. It's literally, you already know how to solve for area, but it's just doing it using fractions, and you know how to multiply fractions. So I don't think you'll have any trouble picking that up. This is just a little bit harder to understand because everyone wants to solve, and you're not supposed to solve. All right, Kaylin, what is going to be my least?
5, 6, 9, 9.
5, 6 times 9. And how do I know that?
Because 5, 6 is less than 9.
Right, I find what I have in common. And then I look. So then I know my equal to is going to be 11 11ths because what? 11 11ths is the same as a whole. And then 5/3 is an improper fraction. So I know if I multiply it by 9, I'm going to get something bigger than 9. Something greater than 9, okay? So now, let's look, I think it's, here we go. This is good.
No, this isn't the same one. This is actually.
All right, I'm multiplying fractions by fractions. Maggie, what do I have in common?
The 7. No.
9 7ths, 2 9ths. Greater than 1, less than 1, or equal to 1?
Less than 1.
Less than 1. So if I multiply by 9 7ths, I'm going to get something smaller than 9 7ths. So I know 9 7ths is bigger. What do I have in common here?
1/4.
1/4. All right, 5 7ths. Smaller than 1, bigger than 1, equal to 1.
Less.
Smaller. So if I multiply by 1/4, will that make 1/4 smaller, bigger, or equal?
Smaller.
Smaller. So I know 1/4 is going to be bigger. All right, we have 3 1/2, 3 1/2. Those are what I have in common. I'm multiplying by 7 6. Greater than, less than, or equal to? Greater than. So when I multiply by 3 1/2, it's going to give me something bigger than 3 1/2, okay? Something greater than. I have 5 6 in common. 9 5ths. Braylon? Greater than, less than, or equal to 1?
Greater than.
Greater than. So when I multiply by 5 6, it's going to give me something bigger than 5 6. All right? See how quick that goes once I know my rule? It doesn't take long. It's just understanding what to look for. That's why I like to find what I have in common, and then I underline it so I know what fraction I need to look at. All right, so now let's look at this one. I need to make this true. I have to make the numerator. It has to be equal to. I'm comparing 19ths. So what does this have to be? I have to have 5 5ths, right? All right, now I have 13 9ths and I'm comparing it. This is going to be greater. So what has to go above my 4?
It can be a 5, 6, 5.
Literally anything bigger than 4, right? So I can do 5 fours. I can do 6 fours, 7 fours. It does not matter as long as it's bigger than 1, Addison. All right? Listen. What am I comparing here? 1/5. All right, and it's saying that 1/5 is bigger than whatever I'm multiplying by. So what can I fill in? I can do a 1/3, or I can do a 2/3. It doesn't matter as long as it's smaller than 1. 0/3 doesn't. You can't do that because like that wouldn't be. Yeah, it wouldn't be. All right. Yeah, it'd be a 0.
It would just be nothing.
If you had, all right, if you have 3 apples, all right, or you're supposed to have 3 apples, but you don't have any apples, how many apples do you have? 0, because, so you can't have 0/3, okay?
You have no table.
We have no table.
All right, so real quick, let's look at these. All right, Maggie, what am I comparing in each of these?
3/4.
3/4. I find my 3/4. 6 6. Where's it gonna go?
Middle.
Middle. 6 6 times 3/4, and I know that because why?
Because 6 is equal to whole.
Yeah.
Exactly, and I know that 3. If I multiply by 3/4, I'm still gonna get 3/4. Braylon, what about 2 2/5? What if I multiply by 3/4?
Less.
Greater than.
Greater than. Yep, look at that mixed number. And I understand because let me tell you, when I go through these fast, I want to say, I see that 3/4 and I'm like, less than, immediately. but I have to think about what I am comparing. That's probably why fractions are a little bit harder than whole numbers, because you're used to comparing that whole number. But don't let it trip you up if we're comparing fractions together. The rule still stays the same. 3/4 times 2 2/5, it's going to be bigger than 3/4 because I'm multiplying by something bigger than 1. All right? And obviously 3/4 times a half. A half is smaller than 1, so when I multiply by a half, I'm going to get something smaller than 3/4. All right, and here's why when you multiply, you get something smaller. So think about when we're multiplying fractions, the word of. The word of is really important because that means that you're going to multiply fractions. So basically, let's say I have a line, okay? I have this line, all right? Now, this multiplication problem, 3/4 times a half, is basically saying 3/4 of that half. So if I have a whole, then I take half of it and I divide it into fourths, right? 1, 2, 3, 4. You see how I only took half of it and divided it into fourths? I'm saying I only want 3 of those. So you see how it gets smaller? I have a half, so this is my whole line. I take half of that line, and then I divided the half of that line into fourths, and I only take 3 of them. When you multiply, it gets smaller. When you're multiplying by something less than 1. All right? So now, let's see. I think we probably got like a few more minutes. I want to look. Let's just do this really quick, and then we'll be done. All right. What are we comparing? So my 3/7. Underline my 3/7. Okay. I don't have to look at it. Okay, 2/3. Greater than 1, less than 1, equal to 1. Less than. 2.
Greater than.
Greater. 1 1/4.
Greater. Less.
5/12.
Less.
3/7. Sorry. Look at me go.
Equal.
Yes, equal. All right, 7/3. Greater. See, I told you we all mess up. I get going so fast, I mess up too. All right. So now I want you to tell me on your hand, 1 to 5. How do you feel now? Okay. So 4 tells me you probably just need some practice, right?
We're like a 4.
Okay.
I'm a 4 and a nub.
So what we'll do, I'll see if the rest of the class wants to play. They like these too. We played a lot of blookets with them to get you going, get that quick thinking going. So we might try to play. I might try to save some room and we'll try to play one of those. Okay?
Yeah.
So it'll help us. But does everyone at least feel over a 3?
Yeah.
Yes. All right. So you think you could? If I gave you a worksheet on it, you could do this.
Yes.
All right. All right. Sounds good. So you can get all your stuff together. We will go back.